Greetings, ladies and gentlemen. Welcome to lesson 15.4. That's page 694 and 695. Our last lesson in unit 15, where we continue to talk volume and today, similar solids. So we're going to use properties of similar solids to solve problems. Our essential question, it's two parts. When the dimensions of a solid increase by a factor of k, how does the surface area change and how does the volume change? All right, so we're going to find that out in just a few minutes. So moving right along, you took notes from the top of page 694 on similar solids. Hopefully you wrote down this, that similar solids, well, they're the same shape and that their corresponding dimensions are proportional. Wow, does that not make it easy? We are masters of proportions. And so that's what we're going to be dealing with this entire lesson, all three videos. All right? So let's get right down to it. We're going to identify if these two solids are similar. Just like we decided, or when we learned how to do our two ratios proportional, well, we're going to create ratios using the corresponding dimensions of these two solids. So we can go a bunch of ways. I'm only going to show you one just to simplify some time here. So on this first one, I'm going to say, hey, I'm going to make a ratio because I know that if these two solids are similar, that their corresponding dimensions are proportional. So I'm going to take the radius of the large one and write a ratio with that and the height of the cylinder. So I'm going to write 8 over 18. And I'm going to say, is that equal to the corresponding dimensions of the smaller one? So since I have the radius on top of the first one, I have to put the radius on top of the second one and then the height on the bottom. So that would be 2 to 6. Now I have two ratios. If this is a proportion, then the cross products are equal. That's what we learned. So 2 times 18 is 36 and 8 times 6 is 48. Are these two solids similar? Nope. No, they are not, because their corresponding dimensions are not proportional. Let's try another one. So here we have two pyramids. And again, it doesn't matter what shape that solid is. We're just going to write a proportion and we're going to say, hey, are these corresponding dimensions proportional? If so, then these two solids are similar. So once again, this time I'm going to use the corresponding dimensions in a different way. I'm going to say the height of the larger pyramid to the height of the smaller one. So I'm going to go 10 over 5. The height of the large to the height of the small one. Is that proportional to the base length of the larger one, 6? I have to put that one first because I put its height first. To the smaller one, 3. And now that I have the proportion written, I can use my cross products. And I go 6 times 5, that's 30. And 10 times 3, that's 30. Are those two products equal? Yes, they are, which means these two pyramids are similar, meaning they're the same shape and their sides are proportional. Their corresponding dimensions, which could be a side, are proportional. So now, if we know that the corresponding dimensions are proportional, we can actually use these proportions to find dimensions of similar solids. So right here it says find missing measures in similar solids. So we're looking at these two cones and we don't know the height of the smaller cone, but we know its radius. We know the height of the larger cone and we know its radius. And they're telling us that they are similar. If they are similar, we know we can write a proportion to find the missing measure. Oops, so I am going to do that right now by saying I've got the height of the smaller cone and I'm going to do that to the height of the larger cone, h over 18. And then I'm going to use the radius of the smaller cone, 5, to the radius of the larger cone, 15. I know these are proportional because they told me these are similar solids, so I use my cross products. I have 15h is equal to 90. Dividing by 15, I get that the height is equal to 6, and that's going to be feet. 6 feet for the height of that smaller cone. One more time. I have two solids that are similar, and I'm going to find the missing dimensions. I'm going to find more than one missing dimension. I'm going to find the height of the larger one, and I'm going to find the length of the smaller one. So on your paper, you might want to make a little room to do both. Divide it up a little tiny bit. So again, I know the solids are similar, so I can write a proportion. And I'm going to go like this. I'm going to say the height to the width of the first one. So the height over the width. And then on the smaller one, I've got to go the height to the width. 6 to 2. Notice we only have one dimension, the width, that we know on each one. So we're going to have to use that one. And so now I know that cross products are equal. I have 2h is equal to, why did I put width? I was supposed to put 8 in there. Hello. That's supposed to be an 8. And so I know that those cross products are proportional. 6 times 8 is 48. You guys probably noticed that when I was writing and talking earlier, and you found and analyzed my error, but we fixed it. And we know 48 divided by 2 is 24. So we know the height of the larger one is 24 meters. This right here, 24 meters. All right? Now we're going to find the length of the smaller one. And again, they told us they are similar, so we know that the corresponding dimensions are proportional. So I'm going to go this way this time. I'm going to say the length of the larger one to the length of the smaller one, and that's going to be 12 to the unknown length. And I'm going to say that that is proportional to, and again, I'm going to go right back to what we just did a moment ago, 8 for the larger width and 2 for the smaller width. And then I'm going to use my cross products, and I'm going to go 8L, L. Boy, I'm having a hard time writing the correct numbers. 8L. I'm just going to scratch that out and go 8L is equal to 12 times 2 is 24, dividing both sides by 8. I get that my length is going to be 3 meters. So that means this length here is 3 meters. And that's how it's done, people. Let's go to our first quick write, where you're going to have 2 of them. Because the first one, you're going to determine if these 2 figures are similar. And then on the second one, we know they are similar, and you got to find the missing dimension. So you might need to pause so you can get these written down. And then, of course, when you finish both of them, go ahead and take a quick break and come back and join us for our next 2 videos. See you in a few minutes.